Apple's M5 Pro represents a radical architectural pivot, moving away from the predictable performance balance of previous generations to pursue a much more aggressive power model. This shift involves the total removal of the efficiency cores. These low-power processors, or E-cores, are the components typically responsible for handling light background tasks and preserving battery life. This chart shows the structural differences. The M4 Pro follows a traditional baseline: 8 performance cores for heavy tasks, and 4 efficiency cores for battery endurance. On the M5 Pro, Apple removed efficiency cores entirely, utilizing 5 supercores and 10 new mid-cores. There is a financial catch to this new layout. To support the increased data pipeline, Apple now mandates a 1 terabyte minimum SSD. The SSD, or solid-state drive, is the hardware that provides all of your permanent file storage. By removing the 512GB option, Apple has effectively raised the entry price for the M5 Pro by $200. Because of the higher cost and the removal of the E-cores, marketing benchmarks are mostly useless. The value of this machine depends on whether these new mid-cores actually save time in professional software or simply generate excess heat. The forced storage upgrade does offer a concrete benefit. The M5 Pro's SSD read speeds reach nearly 13,000 megabytes per second, doubling the speed of the M4 Pro. That increased bandwidth feeds the 10 new mid-cores, which triggers significant performance jumps in heavy multi-threaded applications. Apple also integrated AI accelerators into every GPU core. An AI accelerator is a specialized hardware component designed to speed up machine learning tasks like image recognition or text-to-image generation. This matrix shows the time saved in specialized workflows. In Draw Things, the M4 Pro generates an image in 39 seconds, while the M5 Pro completes the same task in 18 seconds. The second row tracks 3D rendering in Blender. The M5 Pro finishes in 35 seconds, aided by a 50% increase in hardware-accelerated ray tracing. Ray tracing is a technique that calculates the physics of light to create realistic reflections and shadows. Audio production also sees a leap. The M5 Pro supports 290 tracks in Logic Pro, a significant jump from the 220-track limit on the M4 Pro. In previous years, reaching these specific performance levels required spending at least $3,500 on a high-end Mac series chip. For professionals in AI, 3D, and audio engineering, the M5 Pro provides the brute force of a $3,500 desktop-tier machine inside a $2,200 laptop. However, that performance narrative breaks down when you move into standard professional tasks like web design or bulk photo editing. In a Figma export test, the M5 Pro and M4 Pro finished in the same amount of time, showing no benefit from the extra cores. The most significant anomaly appears in Adobe Lightroom Classic, where the M5 Pro actually regresses in performance. This chart shows that exporting 500 raw photos takes 7 minutes and 47 seconds on the older M4 Pro, but nearly 8 minutes on the new M5 Pro. Looking at the core utilization data, the cause is clear. The software is currently unoptimized, leaving the 5 supercores partially idle during the export process. This is strictly an optimization bug, as the machine is not hitting its graphics limits or using memory swap. Memory swap is when a computer uses its storage drive to act as temporary RAM when the physical memory is full. For designers and photographers using standard creative suites, the $200 price premium pays for hardware that their software cannot yet use. Removing low-power efficiency cores creates a secondary problem: a massive increase in heat and power consumption during sustained tasks. When all 15 cores are engaged in multi-core rendering, the energy requirements for the 14-inch chassis spike significantly. This graph plots the power draw. While the M4 Pro plateaus at 40 watts, the M5 Pro spikes to 70 watts to maintain its peak speeds. The temperature axis shows the result of that 70-watt draw. The M5 Pro chassis reaches 45 degrees Celsius, making it noticeably hotter than its predecessor. This intense heat triggers thermal throttling. Throttling is a safety mechanism where the processor slows itself down to prevent the internal components from melting. After 3 hours of heavy testing, the M5 Pro's battery dropped to 2%. Under the same load, the M4 Pro was still at 9%. By deleting the efficiency cores, Apple has sacrificed mobile battery life to achieve desktop-level processing speeds. Because of these trade-offs, you should ignore the top-level benchmark scores and focus on a specific decision framework based on your actual daily workload. This quadrant chart evaluates the machine based on your software intensity and your need for battery mobility. For current M4 Pro owners, the data point lands firmly in the skip category. It is not worth spending $2,200 to lose battery life for AI boosts that are likely unnecessary for your current projects. AI developers, 3D artists, and audio producers moving up from M1 or M2 machines land in the upgrade quadrant. This group gains the most from the architecture shift, effectively purchasing a high-end desktop workstation that fits in a backpack. Standard creatives, like photographers and web designers, land in the lower intensity quadrant. These users should look for a discounted M4 Pro. Their software doesn't benefit from the new cores, and the older chip will provide better battery life for travel. Apple has engineered the M5 Pro as a hyper-dense mobile workstation, prioritizing raw calculation speed over the thermal and power balance found in traditional laptops. Treat the M5 Pro as a financial investment in render time reduction rather than a general-purpose battery life champion.